In this problem, we have three forces P, Q, and R acting at three different points of the structure. They are in fact non-concurrent forces, and we are required to replace these three forces by a force-coupled system acting at point D. So, what we are supposed to do is to find the magnitude and direction of this force and the moment of this couple MD. In order to find force F, we have to think as if all the three forces are concurrent at point D, and therefore the x component of F would be sum of the x components of all the three forces, and y component of F would be equal to sum of the y components of all the three forces. So we write the equation x component of F equal to sum of the x components of all the three forces P, Q, and R. This is Px. This will be equal to P sine 40, that is 100 sine 40, and since it points in the negative x direction, therefore the minus sign. Qx is 50 cos 60. This is Qx. This is 50 cos 60 pointing in plus x direction, therefore the plus sign. The force R does not have any x component, therefore the zero term, and Fx will work out to minus 39 Newton. We now find out the y component of F, which again will be sum of the y components of the three forces P, Q, and R. Py is 100 cos 40. This is 100 cos 40 and is pointing in minus direction, therefore the minus sign. Qy is pointing in minus y direction and will be minus 50 sine 60. The force R is pointing in plus y direction, therefore plus 30, and Fy will work out to minus 90 Newton. We observe that both Fx and Fy have minus signs. That indicates that the force F should be in the third quadrant, and the force F shown in the figure is indeed in the third quadrant. Now we shall find the magnitude of the force F, which will be equal to under root Fx square plus Fy square, and plugging in the values of Fx and Fy that we just found out, F would work out to 98 Newton. We shall now find the direction of this force. Since this theta is the angle F makes with the vertical axis, it will be equal to tan inverse Fx upon Fy. So this will work out to 23.4 degrees. So now we have got the force F of the force coupled system, which is equal to 98 Newton in magnitude and makes an angle of 23.4 degrees with the vertical. Now we are supposed to find the moment of the couple MD. Note that the force P passes through point D and therefore would not cause any moment about point D. The force R is acting at D itself, therefore does not have any moment about point D. The Qy component of Q passes through D and therefore has no moment about point D. The x component Qx will have a clockwise moment about point D, and the moment arm for Qx would be the length CD. Therefore, the moment of the couple would be Qx times CD. Qx is 50 cos 60, CD is 1, and therefore it will be 25 Newton meter in clockwise direction. So this is our final answer. And the force of 98 newtons making an angle 23.4 degrees with the vertical, along with a couple of 25 Newton meter in clockwise direction, would have the same effect as the three forces on the body. Now I would like to share with you an important point which may be of help in solving some other problem. Suppose after having found this force coupled system at point D, you are required to find force coupled system at point E, which is the center point of the section AB. The resultant force at point E would be the same as the resultant at point D, that is, this force F would be again equal to 98 newtons, making an angle 23.4 degrees with the vertical. However, the moment of the couple, which can be denoted as ME, can be determined by summing the moments of the three forces about point E. But there is no need to recompute the moments of the three forces about point E. Instead, one could add to the moment MD the moment of the resultant force F about point E. That is, ME would be equal to MD plus the position vector R crossed with force F. This term is the moment of the resultant force F acting at point D about point E. And since F can be broken up into two components, vertical and horizontal, and the vertical component would pass through E and will therefore have zero moment, this can be further simplified to MD, which is 25 Newton meter, plus the horizontal component of force F multiplied by the distance ED. So I hope you enjoyed watching this video, and thanks for watching, and see you in the next video.